Welcome, Jamie.
So, I haven't even started talking yet, guys. So, as we look toward the future, we've talked a lot about some current use cases that people have conducted with Redis. But what I'm most excited about is the future. And to understand that, I want to tell a story about where we come from. So I started as product manager for security at Redis Labs about 6 months ago. And right when I left, the first thing that someone told me was, what do you think the impact would be if we improved the security features of Redis and gave them access control lists, TLS? What do you think that would do to the community? And that's really stuck with me. What would that do for the community? Now, I got here about 6 months ago, and about 1 month in, the first thing I heard was, hey, we're implementing access control lists and TLS within Redis in open source. And I thought, boy, my job just got really easy. So what I want you to take out of today is, one, a conceptual idea of what access control lists are within Redis, how you can use them, but as I speak, one of the things I want you guys to think about is, what is your use case? This is a new feature within Redis, and we are evolving as a community. And I would like you guys to help talk through that story with us as we present one practical use case that could be used in this environment. So my name's Jamie. I'm the product manager for security at Redis Labs. And we're here to talk about security within Redis, particularly ACLs. So what are the new features that Redis 6 will be coming with? So it will be coming with multiple access control list users. So what that means is that the shared secret that exists as an operational connection between a client and the Redis server will now have multiple users. So you can effectively have multiple shared secrets. You'll also have key and command restrictions so that you as a user can define what keys and what commands each of your users is going to have against your Redis database. And you'll also have out-of-the-box encryption in transit with Redis open source. And I just want to take a moment to thank the entire community here. I know a lot of you are new to Redis. I know a lot of you are experts in Redis, and some of you guys are even contributors. So I just want to take some time to give a quick shout out and thank you to the community, because to me, this is a really powerful thing. So I'm going to start first with TLS, because that will be what's least addressed within this talk. TLS is going to have the ability to configure cipher suites. What those are is those are the algorithms that perform the encryption mechanism. It's also going to have the ability to set protocols for TLS, and that allows you to define what the protocols are for things such as PCI compliance. It also implements TLS 1.3, and for those of you who aren't familiar with TLS, one of the big and most powerful benefits for TLS 1.3 is that as a user, you actually remove a full network hop from the TLS connection because of how it's been re-architected. So to improve your speed with Redis, maybe use TLS 1.3. So as we move on to access control lists, one of the most fundamental things of how we're going to implement access control lists is the key design. So Scott talked a lot about key design today. And I think this key design is going to be one of the most fundamental ways that you can use access control lists within Redis today. So as many of you are familiar with how basic key design works, you typically have an object type, an identifier, and sometimes even a name after that identifier, but that's optional. One of the ways that you might be able to leverage access control lists is with a namespace or a security label. That security label could be used to help define what keys someone can access and what you believe should be the key restriction patterns. So Redis access control lists is going to help you enhance your operational security. And to really demonstrate this, we want to show a demo. So today, I want to teach you what access control lists are within Redis Enterprise and within Redis open source. So first, you can see that I've created a few keys at the top. Those keys here are secret, which is the security label, users, which is the object, one, which is the identifier, and password, which is really an optional name. You can see the value is an MD5 hash. That's actually the MD5 hash for password. And that the security label is secret, which can be very strictly defined. And what that means is that a user will not be able to access the secret key pattern if you have defined their access control list user to not. So what I want to do is show you a quick demo. So ACL list is the command that you can use to see all of your users within open source. And I want to point out a few things at the top. So first, you can see that the default user can be turned on and off. That's going to be an important thing when it comes especially to PCI compliance, when the mandate there is that default passwords are always either changed or that users are removed. Another thing that I want to point out is that you can add and remove specific commands and command categories. Command categories we have linked together within Redis open source, and the contributors there have worked to define and categorize each one of our commands. So you can categorize commands as all commands, read commands, write commands, and we've even defined dangerous commands that can help you decide what commands you want your access control list users to use. We also have a key pattern restriction for each user. So every user can either have, one, access to all keys, or two, access to only specific key patterns. So there's no blacklist approach to keys. You cannot deny a user X key pattern. What you can do is whitelist only. And what that means is, as an organization, key design is going to be a fundamental tenet on what you do in order to define your access control lists. So let's see an example. So I can now set users. And what I'm doing here is very bad copy pasting. So let's set a user Itamar. So ACL set user Itamar. You define that as a user who is on. It can also be turned off. You can define a password, and you can define specific commands that you want and specific keys that you want. So let's give Itamar access to every key. So what you can see here is when we do the plus symbol, we are adding a group of commands. When we do the tilde symbol, we are restricting the key space for this user, and this user actually is being given all keys. And we are turning them on with the password password. We can also, if we are in an environment where we are setting a password, we can also pass in a hash of the password if we are afraid that that password would be logged, say, in a command line bash. So to demo this, I want to show you a database that we've created. So Kyle reminded me very early on during today that I should change my entire demo to use scan rather than keys, because keys is a high performance degradation within the database. So you can see here that we've designed our keys to have data classification labels as the security label. The security labels here are public, top secret, and secret. And as you look at ACL list here, you can see that we've already predefined some users who have access to those specific security labels, as well as some specific commands that will be needed. And this is what I get for clicking through too fast. So ACLs also allow you to restrict commands. So a lot of people used to open Redis to the world. In 2017, you saw Redis open source being a compromise attack for a crypto mining campaign. And what we did then was implement protected mode to help people to mitigate that. But as an attacker, my compromise path would very simply be add a new user, check what user I am. Here you can see I'm the default user. Set a user. This user is now the backdoor user with the password pwned and access to all keys. I would then run a keys command or a scan and see all of the keys. I would then check the type of those keys, and then I would have access to the actual data. So that would then be the goodies. And to me, this is a really powerful thing about ACLs, because this attack pattern can very easily be mitigated just by defining what you want to do with your application. So to err is human, but planning really will always help. So here I want to give you an example of that. So let me authenticate to the user service account. And you can see that the service account user has access to only the secret key pattern. So ACL, who am I? Perfect. You can see that I don't even have access to ACLs. That was completely unintentional, but fantastic example. So I do have access to the secret key pattern, and you can see here that we have defined a user with their credit card information, their social security number. You can even see with their gender. And that's something that you might want your service account to have access to, but not maybe a DBA persona. But that said, maybe let's check something that we can't access. So scan 0. So let's try the public inventory table count. And you can see here that if I check the type of this, I don't have access, so I'm going to guess. Perfect. So you can see here that I don't have access, and that is because I don't have permission to access the key used, because it is public. So if I were to switch users and switch to user 1, this is a user who you may want to access public information. And you can see here that I don't have access to run hset, because this user does not need to access keys that run the hset command or that are of hash type. And right now, think of the operational burden that that could lift off of your shoulders. You can now define what exactly your application is going to do, change on the fly your users if you need to add different key types, and you can also restrict for operational security to make sure that someone isn't accidentally creating something, or if an account is compromised, that you limit your exposure as much as possible. So what are some personas that you as an organization might want to use ACLs for? Well, you can use them for service accounts. Those service accounts are going to be your standard access pattern that you're used to. You can use them for unprivileged users, and you can use them for privileged users. And in that way, you can define exactly what you want. So at the beginning of this talk, one of the things I wanted you to think about was, what is your use case? When I've talked to people here, I've heard that this would be a really powerful streaming pattern. You can define someone who is a writer and another account who is only a reader. And that way you know that those accounts are only going to access the things that they need to do their job. But I want to open it up for a little bit more conversation. As we define this with the community, what's your use case? Thank you, guys.
Great, thanks a lot. Okay, we can do this in one of two ways. If anybody has a question that they'd like to ask, yes, okay, right there. We can take questions now, and then also we can continue this out in the reception area. Here you go.
I was just wondering if MD5 is the only way that you have to secure passwords.
That was actually the value. All passwords must be hashed in a SHA-256 hash. I just happened to have hashed that just because it was the first command that I thought of.
Okay, all right then. I think we are done with questions for now. All right. Thank you very much, Jamie.